My name is Connor Stedman. I'm an ecological designer and farm planner and someone trying to be a useful human being at this time in history. Maybe so. And I've been working on issues around agriculture and land use and climate change for the last decade or so. And talking to Sue about tonight, and so I'm curious, how many folks were here when we had a conversation about climate adaptation in this room some time ago? A few folks, okay. Yeah, so one of the things we were talking about was wanting to dig a little deeper into some of the specifics of some of the specific land use challenges that are being driven by climate change right here in Dutchess County, here in this region. So some of what happens tonight will be review from last time for those of you who are here, and some of it will be honing in a little further on some of these things. I do want to say that this is specifically not a conversation that's intended to be a debate about the existence of or severity of climate change. So I will not be addressing questions like that. I do want to know what questions you all are coming in with. And so I'd love to have everyone introduce themselves and say your name and where you live. And if you can give us a tiny image, like if you have a relationship to land use, like if you are a farmer, or if you are on the Conservation Commission, or if you have some other role around land use decision making, that would be good to know. And if there is a specific question you're hoping could get answered tonight, I would love to at least know what that is. I cannot promise that I will answer it, but at least to know what questions and curiosities people are coming in with would be real helpful. So why don't we just start right here and travel around.
Good. Hi, I'm Nancy. I grew up coming to Ankrum, where my grandmother bought a farm in 1946. And now my brother owns it, and I've been in Guatemala for the last 2 years, but I'm back living there, and we're trying to decide what it is. Most of it is woods, and so I've started managing the woods, but really what is the best use of that land, and also how do we make it more regenerative?
Great, okay. And do you have a question that you're,
Yeah, well, that's pretty much like it's pretty broad-based as far as, I mean, I think there's a lot of things we can be doing with it. It's just where to start.
Okay, cool, thank you.
And I'm Jamie, and I live in the city and also in Columbia County, and we have a goat cheese operation. And my specific questions about right now is, I'm assuming we're going to have more precipitation, more unpredictable weather patterns, and more storms. So we've chosen goats, so they like to live inside, but how does that really fare for all the other things we want to do on the land?
Great, thank you.
I'm Holly Johnson. I grew up on a farm in Mississippi. I didn't pursue farming, I pursued engineering, but most of my friends for the first 30 years I was working were farmers, and so I stayed in touch. And now, for the last 30 years, I've been following the climate change discussions and debates and measurements and writings and whatever. And one of the things that bugs me is that it's probably not something that we're concerned above this level, but the subsidizing of building and development in the flood zone.
Mm-hmm, mm-hmm.
And the subsidies, it creates all kinds of trauma for people.
Right.
So I think we should abandon that.
Right. Cool. Thank you.
I'm Joan Buck. I rent on Orchard. It's the third place I've rented
in Rhine Cliff. And right now, I'm getting a little obsessed with the fact that I might have a very tiny garden that's on the edge of a cliff. And marching up the cliff are out of control maple saplings. And as far as I'm concerned, coming from Europe, maple trees are very large trees. They're not crazy grasses that are climbing up, in this case, the side of my cliff. So I think this has to do with climate change, and I think I'm seeing a micro version of the macro problem. And I love confirmation from you. Am I, projecting on these maple saplings? I don't think I should have 650 maple trees climbing up the cliff in my tiny garden.
Very interesting. Thank you. We'll see.
She's my friend.
Yes.
I'm Margaret. I'm a Rhine Cliffer for many 15 years or so. I have a small garden in the back. I grow some medicinal plants. My concerns are big ones. Now I have a kitty cat, and he's not getting ticks and fleas this year, which sounds like a good thing, right? But they chemtrail 365 days out of the year. It's killing my cedar, I believe, because my cedar used to be really healthy before the chemtrails came every single day. So there's a lot of, in my mind, a lot of geo-engineering that's going on above us that we can't do anything about. And, fracking in the groundwater, all sorts of problems like that have to do with big industrial corporations. So that's my beef.
And what is your question? I'm actually not inviting beefs here as much as questions.
No, the question is, can anybody do anything about chemtrail?
Okay.
Can anybody do anything about the fracking? Can anybody do anything about the fluoridation in the water? The heart systems, the NextRads that are screwing up the environment.
Thank you.
I'm Margot. I'm in Rhine Cliff across the street. And I'm more here, I'm curious. This is our world today, so I just want to know more about it. And also, don't know if this is off topic, but
Can you speak a little louder?
I can. I'm so fascinated by the expression of water in Rhine Cliff.
Yes.
There's so much of it
Running down the hills.
under my house. So, I don't know, water tables, anything about that.
Great. I think that's what we might actually be able to address.
And the maples, right? And the maples.
And we'll see about the tables. Yeah.
Mark Power. I live out in Red Hook. I've been here for a little over 4 years. No specific questions, just curious.
Great. Thank you.
Richard Kopashansky, I live in Rhine Cliff. I built a house in the woods back here 2 years ago, and I'm doing everything not to plant grass because I don't want to mow grass, so I'm planting a lot of flowers, wildflowers. I'm collecting the seeds. I also help Sue in her garden up here, so I'm really into the earth. I love it a lot. I love this earth. I didn't come with any specific questions, but I always like coming to hear you speak, and I always learn something, so that's what I'm here to do.
I'm Susie, and I live in Rhine Cliff also. I have some land that I'm trying to figure out what to do with. It's a former orchard. I also, my question would be what are strategies that we can use to deal with, the broader issues of climate change and consequences.
Right.
I'm Reynolds Tate. I live in Rhine Cliff at the moment, have for 15 years. We've bought, my wife and I have bought a farm in Columbia County, just over the Dutchess County line, to retire to.
Yeah.
And it was an abandoned farm, so we've been working for 3 years now to get it back so that it can be farmed in some way, shape, or manner. And we're looking to figure out, we have water issues up there. And
Too much or too little?
Too much. And we're looking to find ways that we can correct those problems and what else we can do with the farm.
Right, okay. Thank you.
The same.
Anything you want to add?
No, it just, I've enjoyed this series, and I enjoyed your last lecture. It was always, as Richard said, there's always something we can learn. Okay, thank you.
My name is Rich Feldman. I teach environmental science at Marist College. And I'm especially interested in how we're going to cope with the intense rainfalls that we're getting. My specific question would be, what kind of landscaping might you recommend, particularly for urban and suburban environments, and whether integrating prairie plants with their deep roots might be appropriate in a region?
Cool, okay. Thank you.
I'm Steve. I live in the village of Rhinebeck here for 34 years. I just have an interest in the topic. I would say my relationship with the land is that I'm just an avid user of it. I hike a lot and run the trails, so I'm interested in land use.
Right, thank you.
Hi, my name is Deliana, and Connor, I was at your first lecture here, and since then I became a big fan of yours. This was so awesome and so informative. So thank you for coming again. It's wonderful. So I live in Barrytown. It's part of Red Hook town municipality. So I have two questions. What can we, in our private situations, do about the lawns, the grass lawns that are all over? And then, as residents, as citizens, what can we do at the town level or the county level with regard to public spaces and with regard to local regulations that can be helpful? Any suggestion?
Cool, okay, thank you. That's my interest.
I'm Sandy Bartlett. I live in Rhinecliff and I'm the director of the library. And I say ditto to everything. I also would like to know, as you know, as a library, a public space, what we can do to help spread the word and maybe create something here as a laboratory.
Thank you. Great.
Hi, my name is Melanie Gates. I'm on the Conservation Advisory Board for the town of Rhinebeck.
Okay.
So that also includes Rhinecliff and the waterfront. So anything, I plan on taking the points I learned from this presentation and bringing it back to the board. And one of the things, a big part of what we do is make recommendations to anybody who's making a change to their property,
Right.
and vegetation is a part of that.
Right, okay, cool, thank you.
Carrie Truman, I've lived in Norncliffe for, several decades almost. My husband and I bought our house a while ago, and our yard has been this like ever-changing permaculture experiment ever since, which you could also say it looks like a rural equivalent of Sanford and so unfortunately for my neighbors. But I'm especially interested in learning about how to alleviate flooding issues because I share Margot's concern. I live next door to her, and there's been some kind of shift. Something has changed where we're getting, I mean, obviously that's to do with climate, but we're getting more severe flash flooding and erosion, and I'm trying to figure out landscaping solutions.
Yeah.
So I'm especially interested in that, but I'm also just like a lifelong climate change activist, so this is right up my alley. I'm grateful to Sue for bringing me here.
Great, thank you. Thanks for coming.
I'm Connie Lown. I live in Rhinebeck. I'm with the Village Tree Commission. I'm the leader of the Rhinebeck Community Garden. I have a wet backyard at my house. So I'm interested in whatever I can learn and spread the word.
I'm Meg Crawford, and I live in Rhinebeck. Yeah, I've had a nursery for ever since I've been here, pretty much. And I do landscape design. I'm on the Tree Commission. I used to be on the Conservation Advisory Committee. And I'm also on We Leaf, which is an organization at the state level for urban forestry. So I'm really concerned how we adapt tree use to help mitigate the problem, and also how we advise people in planting because of the changes the trees have had to go through and species have had to go through as a result of the changes.
Great, okay.
Hi, I'm Marty Korn. I'm with Woodstock Ecology Events and Festivals.
Okay, yeah.
And I've put together an initiative. We're having a 3-day festival next year in Woodstock, and also with Eco Alliances, which produces sustainable, cost-effective solutions to global warming.
Great.
Hi, I'm Linda, and I'm a choreographer and teacher.
Oh, very good. And then the man behind the camera here.
Questions? No, I don't, unfortunately, I'm sorry.
Maybe we can all leave with more questions than we came with, hopefully. So let's see. I wanna build a little scaffolding for our conversation first before we dive into some of this here. One of the things just to say that what I'm gonna present tonight is my best current thinking on some of these questions. It is not true, but it's my best current thinking from a transdisciplinary perspective on climate change. I am a generalist and a practitioner and an educator and a designer. And those are all roles that have required me and asked of me to be able to think across multiple disciplines and to think across multiple, even at times multiple paradigms and cosmologies. So I take what I'm saying as a hypothesis, as a premise, and see what it leads you to in your thinking when you base it there. There are some ways of thinking and ways of knowing and ways of working together that are well adapted to our current crisis, and there's some that are not. And it's a useful practice to observe my own way of thinking and observe my own way of working as it's happening. And one of the things I believe strongly in the current times is that level of self-observation is going to be required in order to get anything useful done. So from that point of view, you know, the world is like this vast thing to learn from, and that includes trying on a question, trying on a thought process, and seeing where it uniquely leads you. Because I don't have answers to these questions. I have proposals, and I have suggestions, and I have best guesses right now. But really, the knowing will be in the doing. The knowing will be in the place-based doing, right? Because there's one of the real weaknesses and gaps in the scientific paradigm is the belief in replicability of information, and the idea that if something was true once, it will be true again, and the idea of placelessness of information, right? Whereas in fact, the story and experience here in Rhinebeck is very broadly similar to across the river in Kingston, but it's subtly different because the land is different, the place is different, the story of the place is different, the people are different, right? So I'm very interested in context, and I'm very interested in the remembering of context, the putting back together of context, and I think you can see all around us in the world right now what happens when all context is lost. The other thing I want to say is that, so let's see, I want to say something about the apocalypse. So, isn't it funny that there's an increase in apocalyptic thinking currently in the world? Isn't that fascinating? Why could that be? I want to say a few things about that. The idea of an apocalypse has particular historical and social roots. That is not an idea that has been eternal in the human mind. That comes from a particular time and a particular perspective and a particular cosmology. And I'm not going to get into that in depth right now, but it's worth looking into where that idea of the end of the world comes from. And it's also worth saying so my colleague and teacher and great inspiration in the work and communities and movements that I'm part of, Leah Penniman of Soulfire Farm, just published her book, Farming While Black. And it's really extraordinary. It's really, really worth reading and diving into. And one of the things she talks about is how when enslaved people were brought from Africa by force to this continent and built the wealth that we now all enjoy in the United States, they were facing no future. They were facing no possible future. They were facing an apocalypse. And in the face of that apocalypse, people still braided seeds into their hair. They still smuggled seeds in the sewn lines of their clothing. They still brought the entire biological basis of their agriculture with them. Going to God knows what, right? So, and all kinds of other people who face genocide and who face war and who face just the absolute impossibility of their world falling apart have kept the seeds of something alive in the face of that. So I want to uplift the role of courage in the times that we're living in. Because if those people had the courage to still have babies, still smuggle seeds with them, still bring the precious things of their culture with them as they were displaced out of their lands, then we sure as hell better have the courage to do something about the situation we're in and to keep something alive for beyond our own lifetimes. There is no plausible scenario that I can see in which 20th century temperatures will return in our lifetimes, or anything really closely resembling them. We're way past that point, politically and in terms of carbon emissions and all the other lovely greenhouse gases. So, that said, there's huge work to do between, a 1.5 degrees Celsius temperature rise and a 7.5 degrees Celsius temperature rise. Like where that bar ends up falling and how fast and by when will make the difference for the lives of hundreds of millions or billions of people and ecosystems all around the planet. So where that slider bar falls is hugely, hugely significant. And that's the work of emissions reduction, that's the work of carbon sequestration, and that's not what we're primarily focusing on tonight. But there are huge movements and efforts and projects that are deeply focused on that. And actually just very shortly ago, there was the Drawdown conference at Omega Institute down the road that was focused on that very question about emissions reduction and carbon storage. And a lot of cool stuff came out of that. So, but there's these three distinct responses to climate change that are all necessary. The emissions reduction, the carbon sequestration, and then the climate adaptation. And the adaptation is what I want to focus on tonight. Because if you imagine a probability curve of all possible scenarios of climate change, and you imagine it's something like this kind of curve, where there's kind of a big middle territory where the most likely scenarios are. If things were really, really great, we would stay to this amount of warming, and then there's this tail end to the probability curve. And the tail end is where the really scary scenarios get, and those don't even really come into play until after we're all dead, right? Those are future generations, those are going to be faced by future generations, our children and their children. So there have been events, and I'm not going to recount them all, but there have been events in the last 6 months that have either revealed or actually materially changed conditions towards that tail end of outcomes getting much fatter and much longer. Right. So the outcomes that feel and look apocalyptic are likelier than they appeared, and likelier than any of us would probably like them to be. So I don't say that to induce discouragement, but just to, invite really looking at the fact that stability is not coming back. And that one of the things that means is that the American dream is not coming back. Because the idea of America, which was always made up, right? It was always it was a sales job the whole time. But that idea, if you really look at, okay, what would the conditions be in order for that idea to be possible? A stable climate is one of them. And we don't have that anymore. So there's something fundamentally changing about our lives and about the nature of the society we live in that would be true even if we lived in a much more socially stable society, which we don't. So buckle up, here we go. So one more thing to add to our scaffolding, and again, this is my best current thinking about this situation. So I want to propose that that it would be useful to look at 4 different kinds of land use, 4 different paradigms of land use, you could say, worldviews about land use. So one is extractive land use. So what comes to your mind when you hear extractive land use? What is an example? Mining, great. What's another example? Fracking, deforestation. What else?
Or actually intensive farming.
Intensive farming, sure. Yeah. Yeah, going out and picking my garden clean of all of the tomatoes, right?
Long line fishing.
What's that?
Long line fishing.
Long line fishing, yeah. And sometimes short line fishing, So it's the extraction of some form of value out of the land. And there's a way for extraction to work that is within the logic of a living system, right? All species have to extract value from their environment and other species around them in order to survive. So it's not the extraction is inherently bad, but it's when extraction is hyper accelerated. When extraction is the paradigm, the focus, what do you get? You get a lot of what is happening. So just keep that paradigm in your mind. And then another one is a conservative form of land use, a conservative paradigm. So when you think of conservation land use or conservative land use, what comes to your mind?
Propagation.
Okay, yeah. And what is the aspect of the resource base that crop rotation is conserving?
Capacity of the earth.
See if you can go one step more specific. What is the
Minerals in the soil.
Okay, soil, right? Soil nutrients, nutrient ions, and minerals. Yeah. Okay, that's one thing. Yeah. What's another example of conservation or conservative land use?
Wetland. Public parks and.
Maybe.
In cities and.
Let's come back to that one. That's an interesting one. I think that actually is in a little bit of a different mindset.
Replanting.
Yeah. Okay, right. So, like for instance, people will use conservation tillage, where on farms where they'll till less intensively. They will leave reserves of trees in their timber cut rather than clear cut. It's a reduction in harm. Right, so it's a harm reduction strategy from the extraction. Right, we could use quite a bit of that currently. That would be very helpful. There's an important role for conservation, but conservation is fundamentally about reducing harm. Right? So a third approach to land use is restoration, restorative forms of land use. So what's an example of that you think of?
Replanting trees.
Yeah, replanting trees, right?
Farm reclamation.
Wetland reclamation.
I'm sorry, say it again.
Wetland reclamation.
Wetland reclamation, okay, right. Doing the really difficult work of actually trying to restore a whole wetland ecosystem. It is about taking something back to its previous conditions.
What about bioremediation?
Right, and that's a good example, right? I mean, I think bioremediation is usually actually a form of conservation in that it's trying to reduce harm that's already been done. But, yeah, it would be, wouldn't it be amazing if we could, restore the American chestnut to the forests around here? That's a really big project that's out there right now that is in a restoration paradigm, right? But the challenge with restoration is that the baseline no longer exists, right? The previous conditions are gone, right? They've really fundamentally changed. So the question always becomes, what are we restoring to? And so there is a fourth approach to land use that I want to just drop in your pond here as a thought, not as an instruction manual, but just as a possibility, which I'm going to call regenerative land use, a regeneration paradigm about land use. And so regeneration is different than conservation, and it's different than attempting a form of sustainability, and it's different than restoration. Because all those things are related to the measurement of a single variable in some way. But regeneration is about the living processes of the land. It's about the living processes of the land body, right? So if you imagine like this parcel of land where the library is sitting, this parcel of land was not always just this parcel of land. There's a history to this property line. This property line at one point was divided off of some larger property line. And around here, those property lines go back to what?
The duck sub.
Well, in most cases, they actually go back to the English, because the previous lines were redrawn after the Dutch and English War that led to it becoming becoming New York rather than New Amsterdam. So it goes back to the land patents through which this part of the world was basically divided up by aristocracies in England and granted to certain well-connected people who were part of the colonizing process at that time. So, and you can actually find, there's 9 Patents Road out over in corners, and you can find little evidence of this here and there. But if you really look into that story, it's pretty clear that the process through which we got the property boundaries that we have right now was essentially arbitrary. It was basically random. It was informed by market forces generations ago that have no relevance to the world we're living in now, and have usually very little relevance to the land itself, to say nothing of the indigenous people of the land that the land is taken from. So it's a really challenging thing to try to think about regeneration in those conditions, because the land that we're working with, that we have decision-making power within, is a fragment. It's a fragment of a larger land body. And I just want you to see that in your mind for a second. It's a fragment of a watershed. It's a fragment of a mountainside, right? And the natural world works in wholes. It doesn't work in fragments. So we have this huge difficulty, this huge, beautiful, precious, running out of time difficulty of trying to bring wholeness back to fragments. So I just wanted to lay that down here as we start to talk, because these land use questions are inevitably and immediately going to extend beyond a single person's property line. And they're going to require asking questions about common and collective land use. They're going to require asking questions about lands that are held in the public good, lands that are held by networks of people rather than just by individuals. And this is something that Wendell Berry has spoken to very eloquently, where he says, I heard him talk about this the one time that I met him and heard him speak, where he said that the proper use of land needs to become a topic of civic conversation again. It is not appropriate for that to be vested only in private individuals. It actually has to be part of civic discourse. So that realization about how these parcels they're like someone cutting a piece of my liver out of my body and saying, look, it's Connor. Right? And that's really what it's like. And so realizing that presents a real challenge to the way that we have legal rights of decision making currently. And I don't have a solution for that, but I would be irresponsible not to point to it, given our situation. So, with all that said, as if all that wasn't challenging enough, we have climate change and the accelerating impacts on ecosystems and people all around the world. So, what I want to do here is dig into a few of the specific dimensions of the effects of climate change that are currently coming home to roost here in Dutchess County, and will, I mean, under the most optimistic scenarios conceivable, will worsen significantly over the next 20 or 30 years. So it would be really worth wrapping our minds around these things and really coming up with some concrete strategies for how to keep this land alive and thriving and producing and habitable in the days ahead. So I want to start with the topic of stresses on forms of life, stresses on biodiversity and animal populations and plant populations and all kinds of things. And so just to be concrete about some of this, and again, these are broad numbers I'm going to state that are drawn from a bunch of different sources. But broadly, we're talking about, climate change is not just about an increase in temperature, but it's about an increase in variability, right? It's about a widening of variability and a widening of weather and climate outcomes that can happen in any given year. And so that is, in addition to the warming trend, that is really messing with things like the seasonal sequence of things called phenology, which is this flowers after this, and this insect hatches just at the right time to feed on this, and this migrating bird comes back right when those insects are then molting and pupating so that they can feed them to their babies, and the predators who feed on those songbirds nested 6 weeks earlier so that they have all the good fats and lipids of baby birds to feed to their baby birds, and everything kills everything, and everything eats everything, and the world keeps going. So that's really getting messed with right now, and that's related to the mass die-offs of insects that have been happening all around the world. That's related to the mass die-off of amphibian life. There's a lot of pollutants involved in that one too, but as well as with a lot of insects. But a lot of these things are not single-factor causes. They're compounding stressors that make survival and reproduction that much more difficult, that much more difficult, that much more difficult for everybody. So, and in this region, in particular, cold freshwater fisheries are really stretched right now with increased temperatures as well as with, sedimentation and eutrophication of streams. Moose are moving way north currently. They're really abandoning a lot of the southern range of their territory because of all the additional parasite pressure and, tick and mosquito and black fly pressure that they're experiencing there, as well as in some cases, some diseases that they're being passed by other organisms. And then there's the stresses on pollinators that are well known and well documented, and then there's also certain tree species that are really iconic to this part of the world who are facing some real challenges to their survival. And in particular, that's eastern hemlock with the Hemlock woolly adelgid in the region, and it's the ash species, the Fraxinus species with the emerald ash borer. So I wanted to actually put some particular attention on emerald ash borer tonight, because this is something I've noticed people don't want to talk about, is the fact that all our ash trees are dying, and what the heck are we going to do about that? So what I'd like to invite is, some systems thinking on your all's part. And we're going to do something where, we're going to turn to a neighbor, and the conversation I want you to have is, I do not want to attempt to generate any solutions right now. What I want to generate is questions, because it's a really useful capability to be able to ask a good question in order to eventually find a useful answer, right? But the tendency to jump right to the answer without evaluating whether I'm asking a good question or not is part of what's gotten us in this mess. So let's do some leadership practice of asking good open-ended questions and see if you can generate a good and interesting question that you'd like to learn more about that might relate to this question of what the heck to do about emerald ash borer. And just for those of you who might not know, this is the emerald ash borer, amazing animal, amazing life form. It's not a bad insect, right? And this has been happening for a long time. But the ash trees in China, where the ash borer is from, and Japan, they've co-evolved with this beetle. And they've co-evolved phytochemicals that are noxious to that beetle. So, because the temperate China and Japan are extremely similar ecologically to this part of the world. And a lot of the same genuses of trees they're very, very close cousins over there. It's really interesting to look at. And so, there's all these ash trees there that can coexist happily with the ash borer, but the ash trees in North America haven't lived with this borer ever, so they don't have the same phytochemicals. So when the ash borer came in to Michigan about 20 years ago, and started spreading from there, what they do is they burrow into the tree and they form all of these galleys through the cambium. And it after a period of time, girdles the tree and the tree dies. It takes 5, 10, 15 years usually for the tree to die. But in southeast Michigan, which is where the ash borer was first introduced in the 90s, they've been tracking over 99% mortality in ash stands by this point in time.
How did they come in?
It came in wood. It came in the way that...
Pallets.
Excuse me?
Pallets.
Pallets, yeah, wood shipping pallets, it sounds like, yeah. I didn't know that, it's a good detail to know, yeah. So, you know, in the way that the, you know, all kinds of other insects and diseases have been moved around the world, and more to come. More attractions coming soon to you. So let's have a conversation about what would be some good questions to ask in thinking about what to do about this situation in this region. So turn to a partner, try to take at least 2 minutes each to think out loud to your partner about what are some questions you can think of, and then we'll see what people can gather. Oh, we wanted to be up for that up here. Great.
Sometimes you can just import that. So what are all the creatures that take refuge in this?
All right, let's bring it on back. Who's got a really interesting question?
What are those beetles adding to the environment, if anything?
Great question. Awesome, thank you. Something else?
Would this be a valid reason to try genetic engineering to have the genes from the Asian ash produce in our native ash trees the same phytochemicals?
Great. Thanks for that question. Yep. Yep.
Is there a natural predator?
Is there a natural predator? Okay, yeah.
What were the Asian emerald ash borers eating since they couldn't eat the ashes?
Okay, great.
Goodness. Or
What would happen to the overall ecosystem without the ash tree?
Great question.
And
yeah.
follow up, if an Asian species were introduced, how would that consequently impact the local ecology?
Another great question. Yeah.
That was mine.
Okay, yeah. Okay.
We had a question about the insect and how this insect can find other food somewhere
Right.
else.
Okay.
Yeah, if there's no ash trees, what do they eat?
Right. Right. Well, I can answer a few of these questions. So this is an ash specialist, unfortunately. And in China and Japan, they do predate on ash trees, but they don't kill the trees because their predation ability is limited by the tree's defense mechanism. So they've you know, it's like squirrels and oak trees. They've co-evolved this partial predation rather than wiping something out. There hasn't, as to my reading of the research literature, there has not been a predator found for the ash borer yet in this region, which doesn't mean that they're not being predated on, right? I mean, life wants to live, man, and if there's a food source, someone will find it. But that has not had any measurable impact yet on the rate of ash infection and mortality yet.
You said that there was a 99% death rate.
Yeah.
What was special about the 1%?
That's a good question. Right, not 100%. Okay, so one of the, well, let's go to the next slide. So there are lessons to draw from the situation I am proposing from what happened with the American chestnut blight. So the broad story of the American chestnut blight is that the blight came in on timbers from East Asia to Georgia in the 1910s. And, you know, again, one of the reasons why a lot of these plants and insects and fungi are from Asia is because there's parts of East Asia where the climate is so similar to here. So, and a lot of the organisms are related to each other. So it's a very analogous ecosystem, so you'd expect for a lot of those members to be able to grow here, and vice versa. There are North American species that are considered, you know, highly invasive species in other parts of the world that are not considered that here.
Maples?
No maples. No, actually, red maple in some places is. Yeah, red maple, white pine, red foxes, all kinds of things. And by the way, I do want to say that not all species movements have the effects that we're talking about. For instance, coyotes did not predominantly live east of the Mississippi River until the beginning of the 20th century. If you look at old range maps from the old mammal field guides from the 1950s, they show coyotes as question marks in New England and the Canadian Maritimes. Like, we're not sure if they're there or not. We're hearing scattered reports, right? So that's a response to the reforestation of the eastern seaboard after farm abandonment in the late 19th century, coinciding with the extirpation of wolves and mountain lions. So there was a gap in the ecosystem with all these deer finally coming back in, because deer were also hunted almost to extinction in this region. There was no white-tailed deer anywhere in the Hudson Valley in the late 19th century. They were totally gone. They closed the hunting season in the couple of years around 1900 in New York State and Massachusetts and Connecticut, because there was no deer to hunt anywhere. There was one remnant population in the Massachusetts Berkshires that survived that period and repopulated the whole rest of the region after that. So it's interesting, you know, there's been a lot of ecological recovery in this region in the last 120 years or so, from a point of deer being extirpated, turkeys being extirpated, snapping turtles being extirpated, rattlesnakes being extirpated, coyotes not being here yet. You know, almost everybody was gone. So that's hopeful. That, you know, that life wants to keep self-organizing and growing. But when the chestnut blight came in, people realized pretty quickly what was going on, that they were getting, you know, over 99% mortality of American chestnut trees. And you know, American chestnut is this incredible wood, I'm sure you all know, rot resistant and beautiful, and the trees, I mean, this is from the deep, rich hollows of southern Appalachia, but the trees, you know, got to almost redwood size in some places. And so what people started doing is they would, you know, north of where the blight had spread to that point, they would come through and they would, what's called high grade out all of the chestnut out of the forest. So high grading is when you go in and take the best trees and call it selective cutting or thinning. Those are euphemisms you should always peek into a little further, because they generally mean taking the best timber. You want to be asking what the silvicultural techniques are being used, you know, what the selection criteria for the trees are, and so on and so forth. So when that happened, so hardwood species we think of as resprouting from their stumps. And you see out in the forest, you know, you'll see the 3-trunked red oak tree, for instance, out in the forest. And so that's a regrowth from a cut stump that stayed alive. However, each tree species has a age and health status beyond which they generally do not resprout. So with paper birches, for instance, they only resprout when they're quite young. And when you get to, you know, a kind of mature sized paper birch tree, it will generally not resprout when it's cut. Versus an oak of this size generally will, but out to this size they might not. So it's different for every species, but what happened is that all these large chestnuts got cut and died because they were beyond the point of being able to resprout. The younger chestnuts that weren't cut, the ones that got killed by the blight, you know, they're often the ones that we see resprouting in the forest. You know, a little chestnut sprout comes up and there's a skeleton of the previous one next to it because it grows to a certain point, its bark starts to crack and the blight gets in. The blight is still everywhere. But what happened was a huge, overwhelming amount of genetic information was lost through that high grading. And so one of the things that I believe is happening right now is that that's happening with white ash trees, where white ash is this miraculous firewood, right? I mean, you almost just tap it with an axe and it splits apart into these gorgeous rounds and pieces. And, you know, that's the same broad quality that makes its relative, the black ash tree, this just like central, venerated, incredible substance in the fiber arts and basketry and material culture of native people of this region. So if you've ever seen the black ash basketry, that is, very of this place, very of this part of the world, a little farther north from here especially. It's just extraordinary. When you have a black ash basket, what they do is they pound the wood apart into these thin strips. And there's a whole incredible soaking process that goes on after that, and then they weave with it, and you can punch the basket and it absorbs the impact of your pressure and springs back. It's like leather, it's like skin. The white ash doesn't have that same quality, and neither do most of the other ones. But the black ash is precious, so there's a huge cultural loss taking place with the black ash going down to the ash borers, as well as losing these trees in the forest. So what I think when people are going through and cutting out all the ash from their forest to get the firewood value of it before, or the siding or flooring or whatever they're using, before the insects come in, we're losing the genetic information of those trees. So I just want you to consider that, is that there's actually allowing natural selection to take place, will reveal the remnant trees that have some, and there are remnant stands and individuals that are starting to show up in southeast Michigan at the epicenter of the introduction that appear to have some resistance. And that's very interesting and promising. There also have been breeding efforts starting to be done. So just to give you an idea of what's being talked about here, there are a variety of hybrid ashes that have been developed for landscaping, that some of which were hybrids between different Asian species or different European species or North American species. They all have names. They're all, they're used, a lot of them aren't even used very much in North America for landscaping. But some of them have ash borer resistance. And so these are some that are derived from some Asian ash species. One of them, the Northern Gem hybrid, has shown some ability to hybridize with Fraxinus nigra, which is the black ash, the basketry ash I was talking about. So there is a breeding project going on that is attempting to cross these ash with each other to get kind of a robustness of the ash borer resistance in the new hybrid, and then cross that hybrid with the black ash in order to get a hybrid black ash that has the resistance and hopefully still has the wood qualities that make it usable for basketry. So that's one example of something that's going on. And I can't speak to the big kind of ethics and political economy and worldview questions about the GMO question, but it is interesting to note that in the American chestnut work, there's multiple different breeding efforts going on, including GMO strategies, as well as traditional backcrossing strategies like this one. And so this breeding work was only theoretically described as being possible about less than 10 years ago. And it only started to be experimented with about 6 or 7 years ago. So we're at the very, very early stages of figuring out anything about this. But there are people working on it. There are a few demonstration and trialing plots that are in the ground. There's one in Delaware, there's one in Ohio, there's some study plots in Michigan with some of the remnant resistant ones. So when I learn more about any of that, including the discovery of something that could take their place, I'll tell you all. But I think some of you were on a really good track with your questions about what is the nature of the resistance, who else has it, and how can we bring that quality into the ecosystem. The other thing that I think is really relevant to think about here is the fact that climate change means ecosystem transition. That we are not going to keep our forest communities the same. So, and there's a hard both and here, which is that, if you think about plants and animals and fungi and all forms of life, and nativeness is a thing. Nativeness is a real thing, and it's a real thing especially in the sense of the interrelationships between species, right? So there are assemblages of species that have a interdependency with each other and a phenological relationship with each other and a mycorrhizal associates with each other and all kinds of complex relationships that we barely understand that have co-evolved over a million or a few years. But now what's happening with climate change is we're getting these new recombinant ecosystems. And especially this is being seen happening in cities. So you've probably seen, in abandoned lots or street corners or things, there's these wild combinations of plants that have basically never been seen before in the world. And there's some people who are starting to crack a little bit out of kind of a binary native or invasive perspective and just look at these recombinant ecologies that are forming and be like, wow, what's going on here? What are the new associations and relationships that are forming? But there are versions of that that are going to happen in all of our forests, in all of our landscapes. And is there a role for humans to play in that process? Is there a role for, in forests where all the ash are dying, planting something else, to take the place of the ash? Maybe one day we can find the resistant ash genetics in this region and plant those out, but in the meantime, maybe we can start to think about planting some of these. Who's that? Tulip poplar, right? So speaking of another, near redwood size, eastern incredible overstory mega canopy timber tree, we're at the northern edge of their range here, but there's huge tulip dominated forests to the south of us that grow in some of the same soil types that the ash grow in here, right? So that's one thought process that we can engage in is like, what are the conditions that are going to stay the same with climate change, right? If any, if we can find any. Well, the subsoil is usually one of them. The shape of the land is another one. Water's going to change. Species composition is going to change, but the physical land itself usually won't. So, who's growing on physical land like that 100 miles south? What assemblages, and can we not just bring individual species, but can we bring communities from further south and look for places where there's overlap with the species assembly up here? There's really, really interesting stuff to do that is, I think, different than a pure restoration paradigm. And, wherever we can keep the existing species assemblages intact, that's great and important and essential. But a lot of these forests have already changed so dramatically. They've already changed from 3, 4, 5 different deforestation events in the last 400 years. They've already changed from, elk being replaced with cows, broadly speaking. They've changed with wolves and mountain lions being replaced with coyotes and cars and us. What that might be like. Maybe some of these ones want to grow in some of these forests. Who's that?
Black locust.
It's not black locust.
Honey locust.
It's honey locust. Yeah, it's honey locust. So it's a southern, and again, we're at the northern edge of the wild honey locust range here. They tolerate a wide variety of soil types and site conditions. They are a large canopy tree, and they also happen to be a livestock fodder because of the sugary pods they produce.
Are they indigenous?
They are.
Further south.
Yeah, just a little further south. Yeah, or maybe this one. Who's that?
Bur oak?
It's bur oak. Yeah. So in this case, we are at the far eastern edge of the bur oak range here. So it's a Midwestern woodland and prairie tree that has these isolated populations in the Taconics and the Berkshires, and even as far east and north as the Penobscot River Basin in Maine. And there's some archaeoecological evidence that they were actually moved north by native people as part of agroforestry management of landscapes, because they're highly associated with some of the historical farming landscapes along the Penobscot River, way that far up north, farthest north place you can find them. They make the biggest acorn you've ever seen. They're about that big. Huge wildlife food source, huge mass tree source, and again, adapted to a wide range of site conditions, but can tolerate the moisture-richer soils that the ash trees grow on. So I don't have an answer to any of this, but I think these are some of the questions that we have to be asking, and the endless treadmill of trying to contain new species that are never going away might shift a little bit into, recognizing the recombinant ecosystem that's forming and seeing if there are missing pieces we can add to it, or missing pieces we can make sure stay, while other ones are are dying out. So I'll just let that sit for a second and see if there's any reflections. Yeah.
Well, I like this approach, and I'm thinking in addition to warmth, we have to think about moisture.
Yes.
So wood species and communities might be transported from more moist ecosystems.
But also droutier, right? As we'll talk about.
Fluctuation.
So we're getting more fluctuation between intense drought and intense moisture. So it almost is, I mean, there's almost no analog to that in this part of the world. You might have to look at places in China again, where you have interior temperate China. In some places you have this kind of climate, but you have more of a wet season, dry season. So there might be ones there. Or it might be, not the species, but the ecosystem dynamics of like up on the Kamchatka Peninsula in Alaska. Or excuse me, that's over in Siberia, but up on the temperate rainforest where you've got an intense dry season followed by tons of rainfall. What happens with nutrient cycling under those conditions? Those are, and in that case, a lot of the nutrient cycling is about migratory fish, because there's huge volumes of not just protein, but all these micronutrients from the ocean, all this nitrogen that comes up the rivers with the salmon and steelhead runs every year. And on the west coast, at least a lot of the salmon species, they'll actually die when they spawn. The Atlantic salmon go back to the ocean and come back to do it again, but they still get eaten a lot. But the Pacific salmon, they'll actually die, so all of that nutrient ends up in the terrestrial ecosystem. And that was true here too, broadly speaking, in terms of our giant runs of shad and Atlantic salmon and eels and lampreys and everybody. Striped bass, yeah, little ways with the striped bass. Sturgeon. I saw a sturgeon recently. It was on the Kennebec River in Maine. It was the most amazing thing I've ever seen. Have you ever seen one? It's unbelievable. I was fishing in the river and I looked upriver, and this jaw-droppingly enormous fish, 5+ feet long, it was the size of a small human being, hurls itself out of the water like a breaching dolphin and splashes back down in the river. And this is 20 miles inland from the ocean, but they took the dams down. So all the migratory fish are starting to come back in. And then I started going down a sturgeon rabbit hole and learning about the like severe hospitalizations that have happened in Florida because of sturgeon breaching like that, where they leap out of the water with so much force people have had their jaws broken and collarbones broken and stuff like that, literally physically knocked out of their boats by the force of sturgeon breaching. There's a big sturgeon rabbit hole we can go down right now that I won't. But I want to uplift the amazement of these animals, because a lot of these things that are really, really deeply of this place no one's ever seen. And part of that is because they're gone, but there's still sturgeon down at the mouth of the Hudson River. They're still lurking down there. They just have a lot of pollution struggles and a lot of historical overfishing that's kept them being big. Yeah.
So you're kind of stepping off from the Wendell Berry quote,
right?
That these conversations need to be moved back into the civic realm. And thinking about, of course, here you have a room full of very interested people, self-selected.
Right.
How do you see the conversation becoming more of a civic conversation, so that not only do the topics get airtime, but the support is then garnered for the research and all the ways in which this goes beyond being just a nice coffee table, or a coffee table book, or a conversation over coffee.
So the good news is that the zombies are approaching the house, so we don't actually get to just keep it on the coffee table. But no, that's a really good question, and part of my intent tonight is to stir the pot and raise a bunch of things from the surface up to which I hope to do with a few more things here. But I also think there's a really big role for two things. So one of them is personal sovereignty and agency. So individuals have to make the decision to take leadership on something. And me as a sovereign human being, I decide that I'm going to take a step towards X. And as I do that, I'm going to invite another sovereign human being to do it with me. and see if we can build a we out of two I's. I think it has to start with personal sovereignty, rather than with an expectation of participation in a we that actually lacks integrity, because there's not the work hasn't been done to cultivate a group mind and a group heart around something.
Yeah.
The other principle that I would point to is the principle of self-organization, which is the idea that we don't all have to agree in order to do something. So, self-organization, especially with people as sovereign beings, can look like, a group of people, a group of adjoining neighbors want to think about their backwoods together rather than individually. And they want to explore what is the larger story of their three properties beyond just my own property line. And they want to ask some of these questions about, okay, what is the experience of pollinators across all three properties, not just one? What is our experience of food production across all three properties, not just one? I've got a yard that can grow food, you've got a yard that is wet, but maybe there's something in a seasonal cycle we can do together that connects us across those boundaries. That's just one image, Or maybe it's, thinking about, okay, a lot of towns, a lot of counties, a lot of water conservation districts, a lot of kind of smaller units of the public sector have large land holdings of one kind or another. There's town forests, there's town farms, there's big areas of water district land in some parts of this region. And often those lands are held in a, kind of extract value and reduce harm paradigm. Like, extract the value of their recreational use and/or their water purification use, and kind of minimize the damage from those activities, right? But if there's a little bit of a longer-term perspective taken, are there things we want to do collectively, again, with land that are already in the commons, that are thinking about the ash trees, or that are thinking about, hey, we're in this wildlife corridor, and there's things happening with the bobcats and the fishers in this wildlife corridor we don't totally understand. Could we learn just enough to make a best guess at what we should do? And I think that's another principle that's really important, is the idea of, so this comes from something called holistic management, which is planning and decision-making strategy for farmland and grazing systems especially, which are so complex with deciding when to move the animals and to where and forage conditions and all that. So the idea with holistic management is make a decision and do something and assume it was the wrong decision. And then watch really closely to see what happens. And accept feedback and input from the behavior of the animals and the behavior of the forages and the site from the resource base. Accept feedback from the resource base and then adjust the next decision based on what you just learned. And assume that one wasn't quite right either, and look really carefully. So I think that the research and publication-based way of generating knowledge is running into some real limitations right now, where people have to make decisions on a faster basis than that process provides for. And there's big conversations happening in the soil health world that I'm part of about saying, well, yeah, there's these big research questions we have to move forward on, but in the meantime, we know enough about these things to confidently recommend them in most situations. And so we should get started with a lot more of that stuff. I'm sure we'll learn more as we do it, and we'll have to adjust how we're doing it. So I wouldn't center research necessarily as the main thing that's needed. I would center starting to do stuff, and with a lot of observation and learning practices along the way. So hopefully that offers a few things. Yeah. And maybe there's people here who want to get to know each other more and do stuff together, as I know has been happening around this library and around this town for a long time. Okay, let's talk about something else. I'm going to skip this section here. Okay, let's talk about droughts. Fun topic. And actually, for our time, I might skip ahead to the water, because a bunch of people had water questions. We'll come back to droughts if we can. Yeah, there's all kinds of. What are they in the story of Exodus? The plagues. There's all the plagues. You recount them at Passover every year. Yeah, there's all these plagues. Okay, and we'll come back to that. New crops. That's an exciting topic. Harder than you may think. Okay. floods. Torrential amounts of moisture that a number of people have been mentioning. And this year in particular, definitely once the rain started to come back in mid to late July this year, from then until now, there's been about twice as much rain has fallen during that period as normally falls during that period, just to calibrate what we're experiencing. And that's really what's expected, is that precipitation is increasing with climate change. And in this part of the world, there's many parts of the world where it is disappearing entirely. So I would propose that we should be very grateful that we still have water, and that this is a good problem to have. However, also significantly more of our rainfall is falling in large storm events. That actually wasn't the case as much this year. We did have some large storm events scattered through, but there was a lot of this just sort of Pacific Northwest type steady, ongoing, never-ending rain, which maybe we'll have some years like that as well. We don't know. And if it's less of an if, it's more of a when the jet stream totally changes its course and when the Gulf Stream stops, who knows, what the climate here is going to be like. That might have changes that push us back in the other direction towards a much drier climate. We don't know. Yeah.
What's going to make the Gulf Stream stop and when?
The melting of Greenland. So, stay tuned. It's already slowed by about 30% in the last 30 years. Yeah, the biggest place that's going to be impacted by that is Northern Europe. Because Europe is at the same latitude as Labrador, right? But it's temperate because of the Gulf Stream. Because of the tropical water coming from the Caribbean up towards continental Europe. If that stops, you could have rapid cooling in Europe in a very short amount of time. That would change life for a lot of people there. But that's all speculation. There's the broad things we're very confident in, and the way it's going to look region by region is a lot of guesswork. So the other thing I will say, though, that is clear is that we're getting more tropical storms and hurricanes. They're more intense, they're more frequent, and more of them are coming further north because they're just ranging in new directions that they haven't been because there's so much more heat being absorbed into the ocean currently, and especially into the equatorial ocean. And it's that ocean water heat that drives the formation of tropical storms and hurricanes. So, I want to, in the same way that we looked at Emerald Ash Borer, I want to specifically pose the topic of urban flooding and stormwater as a major issue for planning right now. There's also big needs around wet farmland and farmland flooding, and that's a bit of another topic, but I want to focus on towns here because most towns are adjacent to bodies of water in terms of like large concentrations of human settlement because of history of people needing water to do things. And most towns that are near major rivers or lakes or oceans have systems, and this is just one example of the major infrastructure challenges that we're in right now, have systems that are called combined sewer overflows. So a CSO. So who's heard of a combined sewer overflow? The whole front row has heard about this. Okay, so maybe there's even such a thing in Rhine Cliff. So the way a combined sewer overflow works is that back in the early 20th century when the first sewers were being laid in and the first stormwater drains were being laid in, every water basin needs an overflow, right? That's just intrinsic to laying out water basins. And in addition to being a piping system, the sewers and the stormwater drains are also basins in that they can fill up. So what the very well-meaning planners of the early 20th century usually did out of pragmatism and simplicity and maybe not thinking about some stuff that they could have been thinking about is they made the sewer system the overflow for the stormwater drain system. And so in most urban and town water settings in this part of the world, the stormwater system, when it rises to a certain point from a flood event, it backs up into the sewer system. What does that mean? That the sewer backs up into the stormwater, right? So the sewer system is supposed to go to wastewater treatment plants, etc. But what ends up happening is that it goes directly into waterways. And then you get huge nutrient blooms in rivers and lakes. You get huge die-offs of aquatic life. You get algae blooms. You get deoxification.
That's why there's the algae in the Hudson?
Yep, that's a big part of it. And
Except
so,
that's not algae.
yeah, there's other stuff going on there, but it's a big issue in the Hudson. It's a big issue in Lake Champlain. It's a big issue in parts of the Housatonic River, the Delaware River. It's a big issue. Yeah, it's huge, and so you might think, well, and the mindset was, well, the rivers are going to the ocean anyway. Who cares, right? But you know, when you have the recharge of drinking water aquifers from those rivers, when you have inland fisheries that depend on those rivers, when you have recreation that depends on those rivers, when you have all the communities of life, all the water birds and migratory animals that use them, it's really bad news. And it also is just increasing the amount of E. coli that's around, which is not great for human health in any way. So we've got to figure out this. We've got to figure out this flooding and stormwater thing in the built environment. And so I'd like you to turn to partners again and have another conversation. Again, generating good questions to ask that would inform you more fully about these issues of built environment, flooding, and stormwater. So have a go at that and we'll see what you come up with. Okay, take another few seconds to wrap up your thoughts. Get out anything else you want to get out? All right, come on back. So time-wise, I'm going to even go about 15 more minutes here. So for your late-night Halloween parties, you can head out when you need to, but I do imagine about 15 more minutes of this. So, so what are some of the questions you came up with? Yeah?
So how can we encourage more of the surface water to infiltrate and go down to the aquifers?
Great question. Yeah, infiltration rate increases. Yeah. What else?
Ours was similar. How do you turn that problem into an opportunity?
Water parks.
Right, because what could be, you know, it's from a certain point of view, like, hallelujah, it's raining this much. Like, what could be better, you know? There's, there's 30-40% of the Earth's surface that gets, under 10 inches a year or something like that. So, so yeah, what else? What other questions? Yeah.
I was really curious about who does this really well already.
Right.
I don't know.
The Dutch.
Yeah, probably not here in this country.
There are some examples. We should talk about. Yeah.
Well, how can we start recycling some of the, if it's gray water as opposed to mixed water?
Right, okay.
For reuse before it goes into the rivers again.
Yeah. Right, okay, so just to identify the broader thing of that question, that's a really good question. It's about, because currently we basically have a single stream water waste system, right? Where sink water and shower water and sewage water all go to the same place. But what would it be like to separate those streams because they can actually be treated differently? And the gray water, which is everything other than toilet water, the gray water can be treated in a much less intensive manner successfully than the sewage water. And that would be a huge reduction in the pressure on the sewer system if that could be done. Yeah. Yeah.
More permeable surfaces
Okay, right.
for larger parking lots and things
Right.
like that.
Like, have you seen the, this is, my focus is not on specific technologies here, but just as an example, have you seen the permeable pavers?
Yeah.
Where you have, the idea, they're used a lot where you have a sidewalk, but the sidewalk is also the fire truck and ambulance access for a building. And so the sidewalk is only this wide. But then you have permeable pavers on both sides that look like lawn, but they're actually this honeycomb shape of, they're done with cement sometimes, ferrous cement, they're also done with wood sometimes. And so the grass all grows through it, but it has the load-bearing ability to support a fire truck to drive through.
The overflow parking at Northern Dutchess Hospital has them.
Great, okay, yeah. Down over in Western Mass, the Conway School of Landscape Design just moved to a new campus, and they're using a type of asphalt that is permeable, right? So there's also permeable asphalts. Asphalt is always a little bit permeable, but some measurable permeability even. Yeah.
So I have a question.
let's say all the water is going into permeable membrane collector.
Right.
But it's still going to be coming up under my house, right?
Yeah, it might. Yeah, it definitely might. I mean, so, okay, so check. So, so one of our challenges in this part of the world is old houses. Right? And old houses, not just because of all the wildness of heat and cold and moisture and insulation and mold and, oh my God. Not just that, but also where the houses are placed in the landscape, right? So a lot of the time they were placed for proximity to roads. They were also sometimes placed for proximity to water. Back in the old days when people had open water streams running through their basement and that was desirable.
We have that.
Right? Right.
Not every time.
Whereas in a lot of cases, with what we know now and have access to now with well technology, you would actually put the house in a totally different place if you were to replace it. But that's a huge amount of resources to tear down and rebuild. So the retrofit of these houses that weren't actually designed right is a big. I mean, there's a big business opportunity there for people to really think about infrastructure renovation and retrofit. Because conditions have changed, we have better technology now, and and also.
What do you do? Raise it up?
Yeah, and in some of those cases where there still is literally streams running through the basement, I don't know what you would do. Yeah, you might raise it up, like they do.
V-dry systems.
Yeah, but let's see. Is there one more question that wanted to come out? Yeah.
Just quickly, why was it desirable to have a stream?
Yeah. Oh, for drinking water.
Oh,
Before Giardia was everywhere. I mean, we're talking 1700s more than 1800s, but yeah, or at least for drinking water. Yeah. So, okay, so here's some things to think about that I've seen be used successfully that are addressing this issue of increasing infiltration. So one of the cities in the US that has tackled this the most is Seattle. Because they get 80 inches of rain a year. They're actually, it's funny, you think of them as in the rainforest, but they're actually still a little bit in the rain shadow of the Olympics. You get up onto the slopes of the Cascades and the rainfall, 50 to 100% higher there. But they have implemented more of what I'm about to talk about than any other city I've seen. But you will see this increasingly in places around here. I've seen some of this in places in Albany, there's places in New York City that have some of this. But so what this is about is related to this. So some of you who were at my talk before saw this image, but this is about what happened after Hurricane Irene in Vermont. And the issue with places that had permeable area like we're talking about for water to spread out into and slowly dissipate and percolate, rather than a less permeable channel for the water to run through. And so the major variable you want to avoid is the peak velocity of the water. That's the really, really damaging thing in big flood events, is the peak velocity, because that's what influences whether bridges get torn down or not. That's what influences whether houses get carried away or not, whether there's land scouring versus just temporary flooding. So even a longer flood period, but that is less intense, is usually much less damaging than a high intensity flash flood in terms of physical infrastructure. So I'm going to skip this here. So this is an image from a farm that was laid out and managed by a very kind of iconoclastic, idiosyncratic, and even at times evangelical, you could say, farmer in Australia named Parsival Yeomans, who is a developer of keyline water planning, which is it's a system and science of water management that came out of dryland Australia that we've been figuring out applications of here in the Northeast a little bit. But I just want you to look at what's happening in this picture, because basically this is a highly desertified landscape or that's not quite the right word. It's a highly soil degraded landscape from they say that Australia is the place in the world where the most resources were plundered the fastest. And may or may not be true, but it gives you an image of the amount of overgrazing, the amount of flax farming, the amount of land damage that happened in a short amount of time. So when it rains there, you just get these deep gullies that form. It's a lot like California. So what he did was to try to say, okay, when the rain falls, how is it held in the landscape in as many places as possible for as long as possible? How is that maximum velocity slowed way down so that it can actually repercolate? And part of what that was done with was through these basins. So what you're seeing here is these small agricultural dams that are placed at these, they're called key points in the landscape, and there's a whole geometry of how these key points are laid out and how these ponds are linked to each other. So this is the issue of every water basin needing a planned overflow, right? So in this case, there's a whole linked sequence of ponds and basins through the landscape that all overflow into each other. And they all catch water also from a unique catchment, and then they slowly release water into the groundwater into a unique basin below them. So it's a really interesting strategy, and I just want you to see this on a big picture scale, because I'm about to show you some very small examples of the same thinking. But thinking beyond a single property means also really tracing, like, it's a great thing to do to follow the water that lands on your property up to its source. And you can do it on maps to start, but you'd even get together and walk the waterway with people and try to understand where it comes from and what it does along the way, because for the most part, water moving through your property didn't start there. And it doesn't end there. You have an outflow as well. So understanding where you're situated in your watershed is a really big part of piecing together what role you might play in your watershed. And some of the technologies you might use are things like this. So this is a rain garden, and some of you might have seen this before. It's also called an infiltration basin. Try saying that 10 times fast. So the way this works, there's a number of different ways to build these, but the way it works is basically this is a small constructed wetland. And another way of thinking about it is that it's a very shallow pond. However, whereas a pond is open air and it fills up with water, the rain garden or the infiltration basin is filled up with soil. So it's filled up with very high organic matter soil. So usually what we do is a 50-50 mix of the local soil that was dug out to excavate it, mixed with compost. And the reason to do that is it's creating the high organic soil conditions that occur in wetlands that the flood-adapted plants that are going to grow there are expecting and adapting to. And it also creates a significant soil sponge from all that organic matter. So even without any earthworks or basins.
Coming from under?
Oh, I'll get to that in a sec.
Oh.
So even without talking at all about dams or basins or drainages, one of the things you can do on farmland to both drought-proof your landscape and to flood-proof the land below you is increase the organic matter of your soil, content of your soil. Because there's a very linear relationship between soil organic matter and water retention. And it depends a bit on your underlying soil type and a lot of other factors, but broadly speaking, the more organic matter you have, the more water gets held at the scale of like thousands and thousands and thousands of gallons. So here what's happening is, this is not a good example of how this is situated in the landscape, but just to show you the geometry of the basin, where there's a deeper middle part and there's elevated edges, and then there's an overflow. And in this case, the overflow is a semi-permeable dam wall that's kind of like a gabion of rocks. In other cases, it's a solid wall that has a little sluice that it spills out over when it reaches a certain height. And so the way these are used in the built environment is like this. So this may mess up the film here, but I just want to show you this. So this is one of these rain garden basins. And you can't see it because it's filled with flowers. And you might notice that, these are really amazing places to have pollinator communities. These are really amazing places to have native biodiversity come back into the built environment. But the way it works is through this tiny little detail in the design here called a curb cut. Okay, so what's happening is stormwater is running downhill this way, let's say. And then there's just this very subtle cut that angles the water into the basin when it reaches that point instead of picking up speed and going down to the storm drain. And then you've got these curb cuts all along the way so that they're basically like little traps for the water that otherwise is heading right for the storm drain. And so they fill up the basin, and the basin slowly sends the water back to groundwater. And when you build these out over a larger scale in the built environment, it dramatically reduces the stormwater load that these aging, breaking down stormwater systems have to receive, while bringing all this life and diversity and color and habitat back into the urban environment. So they're really cool technologies, they're really simple, and there's just a few little engineering details that they need to work. Often the overflow is like a slightly lower curb cut down here so that the water goes down and then goes into the next one. Sometimes, but it depends on the landform, sometimes you can overflow them into another basin somewhere else.
So you have to get the cooperation of the landowners on the street.
Right, well, a lot of cases like here, they're actually being planted in the municipally managed part of the street. Right, so like for instance, if you go, these are all over the place in Seattle. And especially, you know, those steep slopes in Seattle, they're really concerned with this because they're trying to keep the Puget Sound alive. They're trying to keep the fish populations alive there. So you know, these are really interesting. Like you can dig and plant one of these in a day. You know, they're not hard. And it would be interesting to look at, like next time it rains hard, just walk around town and, you know, gear up, get an umbrella, walk around town and just watch what the water's doing. And watch where the water is just racing towards a drain, where it's creating erosion, and start to think about how can we slow this water down? How can we spread it out? How can we infiltrate it? This is one of a number of technologies that can be used for that, but what I'm trying to emphasize here is the like simple, low-tech things that people can do with hand tools sometimes even. Yeah.
There's a very specific thing in Rhine Cliff of the slopes.
Right.
And the hidden rivers hurling down the slope.
Yes. Yes, so what you want to do, so one of the principles of water management is about managing the water in as high in its watershed as possible. So you want to start the management as high up as you feasibly can, so that by the time it gets to that point, its velocity is reduced significantly. When you can't, if there's water gushing down a steep slope like that, you can't actually manage it at that point. You have to manage it higher up so it never gets to that point. And that's some of the kind of, you know, that's some of the engineering and science of this kind of work. But yeah.
And that concept applies to the entire watershed.
Right,
really.
exactly, yeah.
But then you encounter municipal boundaries and getting cooperation with different municipalities.
I mean, one of the things that the Army Corps of Engineers spent the 20th century doing was installing, you know, really huge, crude versions of some of this stuff all around the big, you know, flood and dam control parts of the areas under their jurisdiction. So these aren't occult technologies by any means. People use them a lot. It's just kind of putting them all together when thinking about a particular place and how to really slow the water down. Somebody back here? Yeah.
I grew up in Mississippi. There are 3 large ponds, if you will.
Yeah.
And then, but upstream, they've put dams across a lot of them that really serve as stock ponds for farmers.
Right.
And it's been working very well for the last 50 years.
Mm-hmm. Yeah.
50 years.
There's a lot of things that can be done, and you know, here, well, I won't get into that right now, but there's a lot more to say. There's a lot more to say about that. But I want to respect people's Halloweens, and we're heading towards 8:45 here, I believe. Yes, we're at 8:45. So I think in recognition of human sleep and digestion and families and everything, we should stop for the night here. There's so much more I want to talk to you all about. But I hope that you will take a moment to make a few friends in the room. You probably know people real well already, but you know, have a follow-up conversation, or at least a recognition of each other before you leave, because there is something important to happen that's beyond the actions of individuals here. And I hope that we've touched on some things that you all might want to try, or even just brought ideas to your mind that are totally different than what we talked about, but are unique and designed for where you are here. Yeah.
I just want to make a couple of comments. It's a very interesting design, and for two reasons.
Yeah.
One, it's easy, right? That's what you're saying. And two, no one else is replicating it.
Right.
No, and I think for me, I studied ecology for many, many years, and, and that is critical. That is a critical issue, and I think this gentleman here, if he is a gentleman, I don't know, maybe not a gentleman. You look like a gentleman. So he asked a question about, I think, how to join more effectively or something like that. And so that's something, I'm addressing two issues with this Woodstock ecology. If I can give an advertisement here.
Please, go ahead, yeah.
The first thing is that there's no, as opposed to the 60s and 70s, I mean, it's like we're on the Titanic, you know, and we have climate deniers at the helm in China and the US. It's just bizarre. And no one is singing about it. There's not one popularly known. There are hundreds of thousands of songs. There's not one. And every time I think about this, it's bizarre.
Yeah.
There's no theme song for ecology.
Right.
Our brain's gonna fall.
Well, if I may
theme
speak
song that everybody knows. You turn, and I've done this to hundreds of times.
Before you go on, I do need to speak up for China a little bit, because China is doing the most of any country in the world right now around climate change.
Please, it's not, I understand that.
Yeah. I'm with you, I just want to recognize that.
That's irrelevant. We're still on the freaking Titanic.
Absolutely.
We better start realizing that if we don't want to go down and go down fast, you know, it's nice about China, and it's being reversed by the U.S.
Indeed.
That is not the way to go. So anyway, there's two initiatives. Woodstock, to find a voice of ecology, which is what I'm doing, but also I'm networking groups and people who are really interested in ecology, and this is I'm inviting people here if you're interested on November 15th, Thursday from 4 to 6. But it's by invitation only, because I don't want to just open. I'm networking groups and musicians, etc., who are interested in ecology to develop resources, do you know what I mean, that are coordinated. Because there's hundreds, thousands of initiatives, but most work in just individuals. So that's the kind of idea.
Where is this happening?
It's in, and I have my card. If people are interested, you know, I ask that they contact me, but it's at the commune at the Bearsville complex in Woodstock. So.
Great, thank you. Well, before we close, I'd like to ask for from a couple of people, you know, in addition to the practice of asking good questions, there's also the practice of reflection, right? So I'd be curious to invite a few reflections. And I think what I'd be especially interested to hear would be valuable would be what's a new thought you had tonight, or what's something new you'd like to try and invite others to try with you. Yeah.
What would happen if the Valoromite was introduced to the ashworm? It'll save two wonderful things, right?
Interesting question. Yeah.
What to do with the actual?
I mean, things like that will start happening. Yeah. Great. Other new thoughts or things you'd like to try? Yeah.
I know in Rhinecliff there's a 10-foot right-of-way that the town actually owns, but customarily everybody just, you know, uses it as their own property. But I was thinking, what if the town took an initiative to do something like this along those right-of-ways?
Right. A stormwater mitigation project across a larger area. Yeah. Which could also be a pollinator bank project at the same time. Yeah. Great. One more. Someone has one.
Encouraging those communities, I like that idea. the southern communities, for example. And I saw a swamp white oak today, thinking,
Yeah.
we probably need to plant more swamp white
Yeah,
oaks.
totally.
We are.
Yeah, I was digging up bur oak seedlings last weekend and moving them around. So,
What
Yeah.
about these maples?
oh, okay. I gotta know a few things. So, how steep is the cliff? Okay. What species of maple are they?
I don't think they're sugar.
They're silver maple probably.
They're, I can tell you the size.
I think what we should do is I should give you my number and you should send me a photo of them.
Okay.
And then I'll think about it. Because different maples are different, right? And different sites are different. But I will say that, we're in a part of the world where, except under some really extreme conditions, every patch of ground left to its own devices wants to become a forest because of the amount of rainfall they receive. So in those conditions, you're going to get woody vegetation as the dominant thing eventually in most places. So, and when you have a large young, even-age stand of the same species, in that case, it might be that maple has figured out how to grow on that site in a way that other trees haven't. But sometimes it's because there was a massed year where all the seeds were available in the environment at one time, and that's when there was disturbed soil and ground, and they all sprouted at the same time. So, is it a view concern? You're worried about them getting too large?
It's more, is this actual tangible growing evidence of climate change?
Right. Yeah, I don't know if that's actually directly related to climate change, but I will say that those types of sites are the types of sites where the recombinant ecologies are coming in first, right? So, there's that steep, I've seen at other steep cliff sites in Rhinecliff where you've got fascinating collections of North American and Eurasian plants growing together that you don't see up on the flat ground where where it's more stable. So,
Oh, that's interesting.
Yeah.
So the combination of instability plus heavy rain.
could have something to do with it.
Yeah.
Can I just say, I have firsthand experience with this.
Yes.
We have an incredibly invasive silver maple problem. I don't know if yours are the same. We're on the other side, we're between Kelly and Tewksbury. But I will say that when we looked at the property, I had never heard the term weed tree before the broker showed us. It's a fifth of an acre, and it was so congested with these maple trees. And he dismissively, and this is a man who loved trees, but he said, oh, those are just weed trees, you'll want to take those out. But it's not an exaggeration to say that the property was so congested with these trees that most people didn't even realize how much land came with the house. And we've been battling them ever since, and this goes back at least, pre-2001, whenever we bought the house. So I sympathize with you, and it may be exacerbated by climate change. And I don't know if anyone else here in Rhinecliff has this issue. I think, Margot, you've got plenty. They pop up.
Yeah, I got just two really quick things about that. So land changes over time, right? So what we're seeing is always a tiny snapshot in a long process. And when you've got a lot of young trees, that's a tiny snapshot in time. The other thing is, if we have feelings and upsets about plants we don't like right now, I have really bad news for you about what the next 50 years is like. We've seen a fraction.
It's just curiosity. Is this the shape of things to come?
Yes. Yes. So we got to figure out how to participate in it, I think, rather than try to hold it back.
Yes.
You go into the maple syrup business.
But they basically carpet bomb your land, the pods.
So I would be open to being sent a photo of that one also.
Yeah.
If you want to get a little more, dig into that one a little
It's
more.
going to
I'm curious.
become a good scientific paper.
I've been told they're silver maples.
Yeah.
But
I'd be interested in that.
what they are.
Yeah. Thank you, everyone. Let's do some stuff.
Because of your involvement with the cuts.